Year 11 homework 8 here. It starts with asking you to fill in this table, these boxes, writing a sentence about each of these reactions or processes. Now, you're not going to get an exam question like this, okay? But I still think it's a useful exercise because it asks you to think back and remember large parts of what we've done in years 10 and 11 and just so you know how things work. So if you can't remember any of these, let's quickly run through them. I'm not going to write the sentence, you're going to have to do that yourself, but I will run through each of them. Electrolysis. Okay, so electrolysis is the process where we break compounds apart. So for example, if you've got, it has to be an ionic compound, something like sodium chloride. Sodium chloride is made of sodium ions and chloride ions. The metal ion, the sodium ion is positive, the chloride ion, the non-metal ion is negative. Okay, now when sodium reacts with chlorine, two elements, when sodium reacts with chlorine, it makes sodium chloride. So the elements turn into ions. Now, electrolysis undoes that process. It undoes that ionic bond. It turns the compound, it breaks the compound down, it decomposes the compound by using direct current electricity, DC electricity, direct current electricity. It breaks it down back into its elements. So sodium chloride is made of sodium and chlorine. Okay, electrolysis breaks that compound apart. Okay, so electrolysis is breaking ionic compounds apart using direct current electricity. Takes the ionic compound and makes it into its elements. Next one, neutralization. Again, another year 10. Electrolysis was year 10, so is neutralization. Neutralization, which is a whole unit on neutralization. Basically, in a neutralization reaction, an acid is neutralized either by a metal oxide or a metal hydroxide or a metal carbonate. The product of that is always a salt, and water. And in the case of the carbonate reaction, carbon dioxide as well. So it's neutralizing the acid using either a metal oxide, a metal carbonate, or a metal hydroxide. Salt and water is always produced. Oxidation and reduction, I'm just going to write all over this, oil rig. Okay, you can write that into your own words, but basically that's a mnemonic. So the O stands for oxidation. Oxidation is loss of electrons. Reduction, R, is gain of electrons. That's a definition that will help you with electrolysis things because something will always be oxidized and reduced. I mean, a much more simplistic definition that we've looked at is gaining oxygen for oxidation and losing oxygen for reduction, and that's also important when you did the metals module in year 10. So yeah, oxidation and reduction flavoured throughout year 10 as well. Distillation, cracking, polymerisation, this is all in the oil unit in year 11. You've probably only just done it. So if you remember, we get crude oil from the bottom of the North Sea, and that is a mixture of hydrocarbons, a mess of hydrocarbons of different chain lengths. Before we can use it, so petrol is one of those, before we can use it, that mixture needs separating. So there's petrol in crude oil. You can't put crude oil in a car petrol tank, it would gum up the engine because crude oil is far too viscous. So we need to separate that mixture. And distillation is the process of separating that mixture. It's a physical process, not a chemical reaction. The crude oil is heated and boiled, and then the fractions are allowed to cool. The fractions are allowed to cool, and they separate because they all have different boiling points. So we can turn them back to liquids at different temperatures. Right, cracking, also linked to oil. Out of distillation, we get a little bit of petrol out of the distillation of crude oil. There's plenty of other fractions in crude oil that could not be put in a car engine because the chain length, the carbon chain, is too long, so that makes them not flammable. But if we can shorten that carbon chain, we make them more flammable. We make them into petrol, if you like. So cracking is taking a long chain hydrocarbon, a long chain alkane, breaking it apart into a shorter chain alkane, a better fuel, and also another product is an alkene, which is a whole different hydrocarbon family, a different homologous series. Okay, if you take all those alkenes, heat them up, pressurize them, that double bond, because they have a carbon-to-carbon double bond, okay, so they have a carbon-to-carbon double bond in that alkene, so here's ethene, say. And this comes from cracking a long chain alkane. You can break that bond open. Okay, you can break that bond open. So I've now drawn exactly the same thing, but with that double bond broken open. Now, if you take lots of them, so let's use N to mean lots, then they can all join together. So they will all join up because this bond here is open, so it just joins to another one of these. So we put brackets through that and we just say it happens N times. So polymerization is the joining up of lots of alkene, lots of unsaturated. These are unsaturated. The joining up of lots of unsaturated molecules to make one with a very, very long chain. This would have, 30 to 40,000 carbons in its chain. And basically that's making plastic. 30,000, I should say, 30,000 to 40,000 carbons in the chain. Okay, so you need to write a sentence about each of those. Right, we've got a calculation now. This says, in an experiment, 0.18 grams of X reacts with 0.34 grams of Y. What is the empirical formula of the compound? So this is an empirical formula calculation. Very, very high chance empirical formula will turn up on your exam. Okay, so topic 1, calculation. Okay, I've got my year 10 book here, and there's a big empirical formula chapter here. Calculating empirical formula. Go back and have a look at this if it helps. So rather than do that question there, okay, let's see if I can squeeze this book in. Let's have a look at what shall we have? Have a look at question number 10 here in your year 10 book. I'm going to do question number 10 in your year 10 book. Okay, so it says, okay, a compound of copper and chlorine. Well, you've got a compound of X and Y. It doesn't matter what these are called. They could be called Bob and Fred. It really doesn't matter. Okay, a compound of copper and chlorine contains 158.75 grams of copper and 177.5 grams of chlorine. What's its empirical formula? Right, so to do an empirical formula calculation, can you divide the page in half, like so? On this side, you need to write the formula, the chemical formula, moles equals mass divided by relative atomic mass. You need to write it there. And you need to write it here, moles equals mass divided by relative atomic mass. Write it out twice because it shows the examiner that you know what you're doing. It also helps you remember it, doesn't it? Okay, now whatever the two elements are, whether it's copper, this one's copper. We'll write copper on this side and write chlorine on this side, okay? In your question, you've got X and Y, so you can write X here and Y here, or as I said, it doesn't matter if it is Bob and Fred, which it won't be, obviously. You could write Bob there and Fred there. It doesn't matter. Whatever the elements are, write them on both sides. Now, we need to find the mass. Well, in this question, the mass is 158.75. That's the mass of copper. Now, the relative atomic mass of copper is 63.5. 63.5. That's on a periodic table if it's not in the question. Okay, you are given in your homework the relative atomic mass of both, aren't you? There is the relative atomic mass of X. So there's the mass of X, there's the relative atomic mass of X. Can you see those? So you're going to substitute your own numbers in. Okay, so now we've got chlorine to do. So we've got 177.5 of chlorine, and the relative atomic mass of chlorine is 35.5. And then you just need to work those out. Okay, get your calculator. Let's work those out. So we've got 158.75 divided by 63.5 equals, and that equals 2.5. Okay, so that's what we write down here now. 2.5. And when we do that one over there, that's going to equal 5 when you put that into your calculator. Okay, so our empirical formula, therefore, is Cu, or whatever you've written up here, so yours is going to be X. I'm going to say Cu 2.5, Cl, chlorine, Cl 5. Okay, now that's not quite in its simplest form, so we need to simplify. If you don't know what I mean by that, you do know what I mean, because if you report a fraction like that in maths, 3/6, your teacher will tell you to simplify it. So you could simplify it to a half, yes? Okay, so to simplify, you just need to ask yourself some questions. First question you ask yourself is, are these numbers the same? And the answer is no, they're not. Okay, if they were the same, then the formula would just be CuCl. It would just be CuCl because they would be the same, but they're not the same. Okay, so the next question you have to ask yourself is, which number is bigger? The answer is the Cl is bigger. So when we come to our final answer, we have to have a bigger number next to chlorine than we have to copper. Okay, so that's really important because most people get this, when they get this wrong, they just reverse the numbers. The chlorine has the bigger number. So the final question, which of those numbers is bigger? Answer the chlorine, and how much bigger? Okay, is it 1 times bigger, 2 times bigger, 3 times bigger, 4 times bigger? Now, to be honest, I've always been quite good at spotting these, whether it's twice as big or 3 times big or 1.5 times as big. So I've never needed really to do any maths about this. Hopefully you can see chlorine is bigger and it's twice as big. 5 is twice as big as 2.5, yeah? So because it's twice as big, the number at the end is going to be CuCl2. Cu1, chlorine twice as big 2. If you can't see that, what you do is you take the big number and you divide it by the little number. And you put that in your calculator. And when you do that, it comes up with the answer 2. And again, back to our formula. The Cl has got the bigger number, so the empirical formula is going to be CuCl2. And that's how we do the maths if you can't see the trends. Okay? Have a go at that. Have a go at that. Right. Next question. Okay, we've got some gas tests here. So, quickly run through these. Okay, the table gives us gas tests, and we've got one bit of information on each row. So the bit of information here is the method, test with a lit splint. Okay, again, I'll talk you through these, but you need to fill this in. There's several gases we need to know. We need to know about hydrogen, which we test with that lit splint. Then you get the squeaky pop, and the way you can do that, you can put your mixture, your reactor mixture down there. Now hydrogen is lighter than air, so you just get an empty test tube and you put it over the top like that. And then over here, you have your lit splint, okay? And then you can move that tube over here after you've left it there for a while, okay? And you hold the lit splint underneath it, that top tube, because the hydrogen given off is going to float to the top. Move that top tube over here, you get a squeaky pop. That's hydrogen. Fill the rest of that in. Ethane and ethene, this is if you are doing separate science only, so single chemistry only. If you're doing double award or combined science, whichever you want to call it, you don't need to know this for Edexcel. That's the bromine water test. Okay, you add bromine water to ethane or ethene. If it's the alkene, in this case the ethene, the bromine water is decolorized. Do not write it goes clear, it is decolorized. Or it goes from orange to colorless. Okay, bromine water is orange. So in ethane, it stays orange. Okay, here we've got a nice bit of a revision to our neutralization unit. This is a metal carbonate, it's reacting with hydrochloric acid. So that makes a salt plus water plus carbon dioxide. So this is going to be carbon dioxide coming out here. How do we test for carbon dioxide? Answer lime water, it turns cloudy. You possibly know that one. Our next test, the result is it relights a glowing splint. A splint relights. That's oxygen. So yeah, if you have a reaction giving off oxygen, you put a glowing splint next to it, the splint will relight if it is oxygen present. Chlorine, finally. This one is litmus paper. Okay. Chlorine will dissolve in water to make an acidic solution. So litmus paper tests for acids and alkalis. It goes red in acid and blue in alkalis. So the chlorine will dissolve in the damp litmus paper. The litmus paper must be damp. If it's not damp, it won't work. Damp litmus paper. So the chlorine dissolves in the dampness, the water, and then it turns the litmus paper red. That's not the full answer though, because of course chlorine is a bleach. So it turns it red and then it goes white. Okay, so the test, damp litmus paper turns red and then goes white. Okay, get all that written in, you'll get 25 out of 25. Good luck.